The next thing we're going to do in this lesson is graph in standard form. Now, standard form is what we are used to when we see our quadratics. This is our ax squared plus bx plus c. So what's nice about vertex form is it tells me my vertex. Standard form does not. So we have to do a little bit of work when it comes to finding our vertex. So your formula to find your x coordinate of your vertex is negative b over 2a. That should look kind of familiar because our quadratic formula starts as negative b. We're missing the plus or minus the square root bit, but then it's all over 2a. So it's like you take that plus or minus radical part out, and that's our x coordinate for our vertex. So then how do you find your y coordinate? Well, if you have half of your ordered pair, all you do is plug that in, and you'll get the other half. So once we get x, we'll plug in x, and that will give me my y. So just like before, my axis of symmetry is my x coordinate of my vertex. So that is negative b over 2a. Now we don't have to find it again. Once we find it here, that is my axis of symmetry line. So example 3, for each quadratic equation, find the following and then graph. So the first thing we need to do is find the vertex. So your vertex, and before I continue, I call this vertex form. My math lab calls it standard, right? So then what I'm calling standard, my math lab calls general form. So just kind of know vertex means standard to your homework, and standard is actually general form in your homework. So I know that's very confusing. So sorry. Okay, so find the vertex. Use your formula to find the vertex. We have x equals negative b over 2a. So my b is this negative 6. So negative 6 makes us a positive 6 over 2 times a. My a is 1 if you don't see anything in front. So we have 6 over 2. And so we get an x coordinate of 3 for the vertex. That's only half of my answer. I need an ordered pair. So now we will substitute this in to get our y. So I'm going to put in a 3 into both of these x's here. So I have 3 squared minus 6 times 3 plus 3. You can just put that all into your calculator. And we get negative 6. So my vertex is at the ordered pair 3, negative 6. So I'm going to put that on my graph. And this one's pretty low, but because my a is greater than 0, it's positive. I do know that this parabola here is going to open up. So that should be the lowest point on my graph. So the axis of symmetry is x equals your x coordinate. And you can see it's my dashed lines here representing an imaginary line. It's going through that vertex at the equation x equals 3. So dashed lines on our graph, and then we will label it on our graph. And now we need to find our x-intercept. To find our x-intercepts, we're going to let y or f of x equals 0 and then solve for x. So I have 0 equals x squared minus 6x plus 3. We have 3 ways to solve: factoring, quadratic formula, and square root method. I can't use square root method when I have a b term. So we have to use one of these two ways here. If you like quadratic formula, you can jump straight into that, but I prefer factoring if it is something that is factorable. So I would come over here to the side and try to fill out this diamond. My A times C is 1 times 3. My B term is -6. So what adds up to 6 but multiplies to 3? I'll give you, pause the video if you want a little bit more time. But the answer is nothing. The only multiples of 3 are 1 times 3, and that doesn't add up to 6. So when that happens, when factoring fails us, we have to use the quadratic formula. So my quadratic formula, and pause the video if you want to try to remember it, is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So right, that's the -b over 2a. This right here is missing this bit right here. Okay. So we have our formula. Let's write our a, b, and c. So my a equals 1. My b equals -6. And my c is 3. So substitute those all in. We have -b, again, minus a negative becomes +6. B squared, when I square this, it has to go in parentheses. Minus 4 times a is 1 times c is 3. Goes all over 2a. So we're going to get 6 plus or minus the square root all over 2. Get my handy dandy calculator here. We're putting it in exactly the way it looks. We get 24. If we can simplify, we need to simplify. So if I take the square root of 24 up here, break that down, that is 4 and 6, which is 2 and 2. So there's a pair. 6 can be broken down, but I don't have any more pairs. So I'm going to multiply that right on back up to a 6. So this equals 6 plus or minus 2 square root 6 all over 2. And it can be simplified one more step. We're looking at only 3 numbers, so be careful here. What's in front of the plus or minus, what's behind the plus or minus, and what we're dividing by, not what's under that radical. So I'm not dividing 6 by 2. So this becomes 6 divided by 2 is 3, plus or minus. 2 divided by 2 is 1, don't really need it. Square root 6. And then all over 1, again, don't need it. So my math lab is just going to want this answer here. I need ordered pairs. So my x-intercepts are at 3 plus square root 6, comma 0, and 3 minus the square root of 6, comma 0. Now, while these are the exact x-intercepts, those numbers don't really help me as far as graphing. So I need some decimal equivalents here. So when I put this in, I got 3 plus the square root of 6, and that's going to be about 5.45 for this number. And I'm going to come up here, arrow, and about 5.55 here. Okay, so now this allows me to graph these. I'm going to go roughly about 5.5 right there, and roughly 0.5 right here. Now I need my y-intercept. And to find that y-intercept, we're doing the opposite. We're going to let x equal 0 and solve for y. Now, when this is in standard form, this is even easier than it is in vertex form, which isn't hard to begin with. I'm going to substitute in a 0 for both of these x's. So I have 0 squared minus 6 times 0 plus 3. 0 squared is 0. Negative 6 times 0 is 0. All I'm left with is this 3 here. So when you're finding the y-intercept in standard form, it's going to cancel out the x squared and the x, and it's always going to be this constant right here. So my y-intercept, again, my math lab just wants y equals 3, but I want the ordered pair of 0, 3. So let's plot that at 0, 3. And I, again, typically like 5 points, just makes it a little bit more accurate. I'm going to use that axis of symmetry for that y-intercept. If that's 1, 2, 3 units away, I'm going to go 1, 2, 3 units away. And here's my 5th point right there. So now I'm going to turn this upside down real quick. There is my parabola. Okay, do make sure that that's not a hard point. It should not be a V. That's absolute value. So the next thing it wants is the domain. The domain, as we go from left to right, we go arrow to arrow. So the domain is negative infinity to infinity. And again, the domain for all quadratics are going to be all real numbers, negative infinity to infinity. The range will be changing though. The range as I go from the bottom to the top, here is where my graph starts, and that has a y value of -6. And that is included, so that's a bracket. And then it's going to keep going up forever, so infinity.